All right, welcome to the Explainer. Today, we're diving into one of Python's most powerful tools, something that will help you write code that's not just clean, but incredibly fast.
So, you've probably been there, right? You've got this huge list in Python, maybe thousands, even millions of items, and you need to find one specific thing. You hit run, and your code just slows to a crawl. It's like looking for a needle in a haystack, and it's just painful.
But what if you didn't have to search at all? What if you could just tell Python, hey, give me this piece of data, and it could jump right to it, instantly? Well, that's not some far-off dream. That is exactly what Python dictionaries are all about.
Okay, section 1, beyond the simple list. To get this kind of speed, we really have to shift how we think about storing data. We're going to move beyond the basic list and get into something, well, a lot smarter. The core idea here, the secret sauce, if you will, is the key-value pair. It's a really simple but powerful concept. Instead of just having data floating around in a list, you give it a unique label, a key. And that key is directly tied to its value.
Just look at the difference on screen. On the left with the list, that number 30, what is it? You have to remember it's the age. The context is all on you. But on the right with the dictionary, the data explains itself. The key age tells you exactly what 30 is. This makes your code so much cleaner and way easier to understand. And this whole key value setup, that's what a dictionary is. Its entire purpose, its reason for being, is to give you that instant lookup we were talking about. You know the key, you get the value. Period. No searching required. Now, to make all this work, there are just two really important rules you got to remember for the keys. Let's call them the two commandments. First, keys have to be unique. You can't have two of the same key in one dictionary. And second, and this is the one that gets a lot of people, the keys have to be immutable. That just means they can't be changed. So things like strings, numbers, or tuples work great. We'll circle back to why that's so important in just a bit.
Okay, let's move on. Section 2, mastering dictionary operations. So you've got your dictionary, now what? Let's go over the essential tools you'll be using pretty much all the time.
Think of these 4 methods as your bread and butter. You want to grab a value without your code crashing. If the key isn't there, use .get. It's safe. Need to merge 2 dictionaries. .update handles that for you, nice and clean. And when you need to loop through everything, .items is fantastic because it gives you both the key and the value together. Finally, .pop is perfect for when you want to remove an item and get its value back at the same time.
All right, section 3, avoiding common traps. Now, knowing the basics is great, but what really separates a beginner from a pro is knowing what not to do. Let's talk about a couple of the biggest gotchas. And remember that second commandment we talked about keys being immutable? Well, here's a perfect example of what happens when you forget. Developer Kieran McCons shared this experience. You try to use something that can change, like a list, as a key, and Python just says, nope. So why does Python do that? Well, think about it. For that instant lookup to work, Python needs to create a permanent address for each key. But a list is mutable, right? You can add to it, remove from it. Its contents can change. Using a list as a key is like trying to find a house that's constantly changing its street address. It's impossible. So Python doesn't even try. It just throws up its hands and gives you that type error. And the fix? It's actually super simple. You just use a tuple instead. A tuple is basically a list that's been frozen in time. Once you create it, you can't change it. It's immutable. And because it's reliable and won't change, Python has no problem using it as a key. Okay, on to the second common trap. And this one is way more sneaky. It can lead to some really bizarre bugs that are hard to track down. So, here's a question for you. What do you think happens when you copy a dictionary, but that dictionary has a list inside it? This is what's known as the shallow copy trap. So you use the standard .copy method. You think you're getting a totally fresh copy, right? Wrong. You get a new dictionary, sure, but the list inside it, it's not a new list. Both your original dictionary and your new copy are now pointing at the very same list in memory. So if you go and change the list in your copy, surprise, the original one changes too. And yeah, you can imagine how confusing that gets. So here's the rule of thumb. If your dictionary is simple, just keys with numbers or strings as values, a shallow copy is totally fine. It's fast and it works. But the second you have a list or another dictionary nested inside and you need a completely independent clone, you have to use a deep copy. It's the only way to avoid those weird, unexpected changes. Okay, section 4, the secret to speed. We keep saying dictionaries are fast, but how fast are we talking? And what's the actual magic behind it? Let's finally pull back the curtain and see what's going on under the hood.
I love this question from a Reddit user because it gets right to a common point of confusion. They're thinking, okay, dictionaries are fast. I know sorting data makes searching faster. So if I sort the dictionary, it'll be even faster, right? And that's a totally logical thought if you're dealing with a list. But for dictionaries, it completely misses the point of how they work. Because here's the big reveal. Dictionaries don't search at all. They don't go item by item, so sorting doesn't do a thing. Their speed comes from something else entirely. It comes from calculation. This process is called hashing. Here's the rundown. You give it a key, say the string name. Python takes that key and runs it through a special mathematical function, the hash function. This function instantly calculates a unique number. And that number, it's basically the exact location in your computer's memory where the value is stored. It's not searching. It's like having a teleporter that takes you directly to the data. Now, in the tech world, we have a way to describe this, called big O notation. Searching a list is called O of n. All that means is that as the list, n, gets bigger, the search time gets longer. It scales up. But a dictionary, it's O of 1, constant time. And that 1 is everything. It means the lookup time doesn't change. Finding one item in 10 is just as fast as finding one item in 10 million. It's always a flat, constant, incredibly fast operation. And that's why that 6.6 times faster idea we heard earlier is just not the whole story. Not even close. For a really small list, yeah, a dictionary is a little faster. But when you get to millions of items, it's not 6 times faster. It can be over 500,000 times faster. That's the difference between your program finishing in the blink of an eye versus you waiting and waiting and waiting. Okay, so let's wrap this up. What are the big takeaways? First, dictionaries give you that instant O1 lookup because they connect unique, unchangeable keys to values. Second, their incredible speed comes from hashing, from calculation, not from searching. And third, the pro moves to remember. Always use immutable keys and know when you need a deep copy to keep your data clean and avoid those weird side effects. So there you have it. You now know the secret to making your Python code orders of magnitude faster. The power of instant data access is literally at your fingertips. The only question left is, when are you going to choose to use that speed?